Okay, great. Well, hello everyone. Happy to be here, or actually he here with you. And for this short talk, indeed, I'm going to present. I'm going to try to cover the recent contribution of the AR group at NeurIPS. Okay, that's why I'm going to mention self-contained and general introduction to our papers. But of course, it's going to be a very, very high level, and it's just a presentation. But first, maybe I want to explain, because I don't know if all of you are fully aware of what is NeurIPS and why do we care so much about this conference that's going to be held next week, actually, in Vancouver. In I don't know if that's actually the place or not. It's just a random picture I took on the internet. Okay, so why should we care about this conference? So NeurIPS is the world leading conference in AI and machine learning and many more. And it has been for almost 40 years now. I think it's like the 36th edition this year. And as you can see, the list of topic on the right is quite broad, and it goes from pure theoretical machine learning all the way to really practical implementation of practical algorithm in application. Okay, so that's a very broad conference, and it's a huge one, as you can see on the left, because the number of papers which are submitted is increasing every year. And it reached apparently this year, because those are unofficial numbers, but apparently there was been roughly 16,000 papers that has been submitted for an acceptance rate of 25% approximately. So we have like 4,000 papers accepted. And what I'm going to describe today is the contribution of Criteo, the AIR, the group, in the two main tracks. Okay, because you have to maybe maybe you know at NeurIPS there is those main tracks, so that's just the regular papers, that maybe 90% of the papers published there, and then there is another other kind of tracks which are data sets and another type of tracks with challenges. And at Criteo we had two papers in each of those sub track, and 13 in the regular track. So what I'm not going to describe is the papers that we might have or might not have at the workshops, because the acceptance rate is much higher, and it's less prestigious, and but still difficult, but less prestigious to reach there. And so of course there's a typo in my slide. Last year there have been 13,000 participants at conference. So of course, it has going to such a conference has a huge impact in terms of PR, and either individually for a researcher or as a group if you have people there. So it's must be a conference. So no, maybe it's just some numbers. So maybe you're for those that are not used to machine learning or AI, maybe you are wondering why should we care about this conference, and whether it's impressive or not. So I wanted to, at some point, give a hint on how difficult it is to publish at NeurIPS. And I spent, okay, I'm going to be honest, last night, I spent quite some time trying to find numbers, actual numbers, and that display the role and the difficulty of publishing there. And I did not find any. And so I was quite disappointed. And then I said, well, we are in the AI or Gen AI world, so let's just ask ChatGPT what it thinks about it. So that's the answer of ChatGPT, and that says, why is it difficult to publish in NeurIPS? Publishing there, as you can see, there is like 5 difficulty or levers to develop. It's highly competitive, of course. There's thousands of papers. It's a rigorous review process. So you have peers, you have professors and or research scientists everywhere in the world that are actually reading the paper and giving their opinion. Even sometimes it's a bit biased, and you have to beat the state of the art, and sometimes even go away from your own field and try to mix your techniques with other techniques. So it's not just uh, writing a paper for the sake of it. You have to be very careful on top of it, because things are moving very, very fast in AI. And you can see, as ChatGPT said, it says that publishing even one paper at NeurIPS is a significant achievement. So we are quite happy this year to have like 13 papers and plus 2, so 15 papers. And as ChatGPT said to me yesterday, he told me that having multiple papers at NeurIPS is a hallmark of excellence and leadership in the field, which is a very good news for the group. And that's why I wanted to congratulate all the participants of AIR for this success. And in the same question they can ask is that, okay, NeurIPS is a conference, but there are many other conferences. So what is one of the main specificity of NeurIPS? Why is it different from maybe another conference? And so same thing, I try to find some objective numbers going online, trying to Google stats or whatever. And actually, it's very hard to find factual numbers. So I just asked ChatGPT the same thing. I asked him to give me some answer to these questions, because I wanted to give an idea on how hard it was for everyone in the air to get a paper there published. I asked him how long it takes to have a paper published there. And as you can see, the main message is that having a paper at NeurIPS is not just a quarter project, is of course a 1 year, even 2 years project. Okay, so you have between 6 months and 1 year of just trying to do the math, trying to do the simulation, or trying to do whatever you want. Then once you're over and you're happy with what you have, you start writing the paper. So it's at least half a year, because then you find all your mistakes and you have to fix stuff. You have no idea and everything. So that's more than 1 year, 1.5 years. And then you wait for the NeurIPS reviews to come in, and you wait for it. And then once you have it, you have to finish your paper, and it takes a few more months. Okay, so that's what it says. That's what ChatGPT is saying, that this lengthy and competitive process is the prestige of publishing at NeurIPS. Okay, so each of those papers is not just a single project, as you said, but it's a combination of sustained effort. It's very nice, resilience, even better, and adaptability, which is, I think, something that describes the group. So we are very happy about all of those publications this year. So that's the end of why I was focusing on why I wanted to give this talk here and say, well, we are publishing on NeurIPS. This is a great achievement, and I want to describe now the different paper. So of course, as you can see, there is only remains 20 minutes, and as I told you, there is 15 papers. So I only have more or less 1 minute for each paper. So I'm not going to describe them in full length. I'm just going to give you insights of what we are looking at, and actually what kind of answer we provide. Okay, the kind of yeah. So first thing first, let me drive this just to illustrate where the group is placing his research. So let's say that's what I wrote, a typical journey of data at Criteo. So when you are a data point at Criteo, then first you at some point the data they will first in the pipeline, they will enter this what I call the pre-processing. So we are building lots of data sets, and from this data set we are building we are making embeddings, we are fitting some function, we are doing stuff. So we are pre-processing the data. This happens offline, okay, every now and then, every 6 hours, say. And then we go on the online setting where data are seen one by one. So when the user arrives, so we have to take a decision, and we have to do some bidding, some recommendation if we win the auction, of course. We have to allocate our budget. We have to to do some planning, some pacing of the budget and everything. And this is online setting, okay, online fashion. And because things happen one by one, we treat them, and we do not update the model at each steps. Okay, so we have to do something in online setting. And then at the very end, after maybe a day, if you want, we have these offline steps where we do post-processing of the data. Typically, we do attribution, or we try to reduce the bias in the data and everything. So we're looking back at the data that we have gathered, and then we are adding them to the data set, and then it goes again and again and again. Okay, so here it's basically the typical process of data in Criteo and in many companies, of course, like Criteo. And so the question is, where does the group do this research? And the answer is quite interesting. It's everywhere. So we'll show you, we have researcher papers on the pre-processing task, papers on the bidding, on the online settings, and we have paper on the offline case, on the post-processing. So this year, that's why it's quite impressive for, I think, for us, that we do have like a large variety of papers on all those different aspects of the chain of data processing. And the thing which is also very interesting is that each of those steps here, they require different techniques, and techniques and tools. And this is exactly what we will see later in the remaining 15 minutes. Is that if you look at the pre-processing task, most of it actually are using deep learning techniques for this for in the papers that we have. And then when you go to the online setting, when you're using data one by one, you can either use online learning techniques or online algorithms, which are actually not the same thing. We'll discuss this quickly, of course, because we don't have time in the future. And then when you're doing the post-processing, the question we're going to ask ourselves is about the fairness of our algorithm and also how we evaluate the different contributions. Okay, so that's how we that's the four type of contribution that we had, and I'm going to describe later. The pre-processing using deep learning, the online setting based either with online learning on an algorithm, and then the offline post-processing of our data using fairness and valuation stuff. So let's get in more details in each of those four steps. So the first one is using deep learning for pre-processing, offline pre-processing. So you might all know, I guess you all know that deep learning is very important right now at Criteo. And deep learning is, of course, nothing more, utmost, I want to say this to be to exaggerate, but deep learning is just a fancy regression, be it logistic or linear. This is just a regression. And what you're doing is actually the feature transformation are not built by hand, but they are learned automatically by the model. Okay, so that's the main idea. The main idea is to learn the feature transfer of your model. And this deep learning has been the basis, of course, of many recent advances. So all the Gen AI, especially the diffusion model. Why? Because you'll see why I'm mentioning those diffusion model later. Some techniques, the encoder and decoder system, instead of building your own encoder and you're letting the machine find it, but also some auto differentiation, some PDE solver. So for instance, right now, some forecasts are actually more efficient, weather forecasts are more efficient using deep learning than the numerical solver. And there are many other variants, especially on games, and that's how you see why later I'm showing this variants on games.
Ah, mais il est en remote. Il est en remote.
Yes, I am on remote.
En train de présenter tes papiers.
And so on this deep learning for offline processing, we have actually two papers and one challenge that has been published by the group. And those papers, especially by Patrick Gallinari, well, actually what they're trying to do is they're trying to interface, actually they're not trying, they managed to interface deep learning and PDE solver for different, for solving PDEs, of course, that's the objectives. And they're doing this by actually putting some diffusion model and some encoder decoder of the data before. It's a line of different tools that use all the techniques I mentioned before in order to get such a results. The point of doing this is actually it's quite interesting because you might think at Criteo that we are not looking at PDE, but this is just right now. Maybe in the future we could go to the mean field limit of our problem. When you have mean field, you can approximate each data point, each user as an infinitely small fragment of a collective one, like in the foundation, for those that have read Asimov. And then using this very tiny representation, you can see that the global population evolves according to some fixed PDE laws, and then we could learn it and exploit it using this kind of PDE techniques. So it's, of course, it's not something that can be used right now in Criteo, but maybe in the near future, hopefully it will be it. And then there's a challenge related to this question of running PDE run by sharing was run by Patrick in part, and where they're trying to use machine learning, as you can see, for computational fluid dynamics. So here I put this challenge here, even though the solution is not necessarily on deep learning, but that's the main idea. Okay, so that was the first three contributions of the group, is on looking at the pre-processing of the data using deep learning. So that's where we are building our knowledge using deep learning. Then we move on the second step. The second step of the data journey, as I told you, is the online settings. So we move from the pre-processing to processing actually the data. And here, as I told you, you can have two major. So we focus on two major techniques for online treatment of the data. It's either online learning, also known the bandits, or online algorithms, the competitive analysis. Both of them are related, slightly related, related notion, but still different. And here I took this opportunity to put them in perspective, just so that you understand which one is which. So when you're doing online learning, so basically bandits, you have typically an environment which is stationary. You have random data that arrives, but you assume that the distribution is stationary. And the thing is that you don't know this distribution. Okay, so you don't know it. You don't know this process. And you will observe some data, you will treat the data, you will do some stuff on those data, you will take decision on the fly, but pieces by pieces, you will learn the stochastic process. You will learn the stochastic process, so you will know at the end of time, you will manage, hopefully, you will manage to learn the distribution process so that you know the optimal decision to make, and you do that by minimizing the cost, the learning cost, the cost it is to build a data set. But here the objective is that since you don't know the distribution process, you are looking at very simple or stationary strategy. And this is typically what we do in optimization or in algorithmization. That's the kind of techniques that we are using. Another way, when you're doing an online algorithm or competitive analysis, things are a bit different. Here we assume that we know the data processing, data generation process. Okay, we know how the data are processed, but the thing is that the environment is dynamic. The data change, the process change every now and then. And even though we still observe the data sequentially and treat them on the fly, so what we want to do is not really learn the process because we know it. What we want is we want to predict the next point, the next realization of the process, and we want to find long-term control of our system. So basically, what we want to do here is we want to do like budget pacing or this kind of questions. So we want to control the problem in the long term, even though we are discovering it step by step. So we are using our budget, for instance, in this budget pacing, we are using your budget bit by bit, but we are trying to find the best strategy. And here the thing is that we are looking at a very complex, since we know the data process, we don't need to learn it, so we can aim for more complex strategy or objectives. So that's why I'm saying that we're looking for more complex and or dynamic strategy. Okay, so that's the two kind of course, there are correlation between them. There are relation between them. Some tools can be adapted from 1 to 0, but it's still a bit different. And this is where we had also a bunch of papers. You know. So we used this those online learning, basically two questions, or three questions actually, three main questions. The first one is the one which is described on this slide, is we used these bandit techniques, these online learning techniques for pricing, finding the optimal price, and auctions. Okay, then we will use also bandit techniques for recommendation. That's the second step, and then I will describe online algorithm, which is used for budget pacing. And we see how we use it for budget pacing and fairness, to improve the fairness of our algorithm. So here, so let me, okay, anyway, we'll look at it here. So here we are, let's focus first on how we use online learning techniques for improving the pricing and auction. So of course, we always are looking at some model abstract setting, but it's always motivated by a question usually from Criteo or Criteo-like. And so you can see this question that we are trying to answer in the paper that we mentioned below. Okay, so what the first paper, which has been written from Criteo, so namely Hugo, Maria, and Clément, is if we are under a privacy sandbox. Under the privacy sandbox, we know that maybe, actually, because nothing is for sure nowadays, maybe we will not be able to see the user feature. Okay, so we will not be able to actually select ourselves a campaign for them. So we will actually, instead of selecting a campaign, we will send a bunch of campaigns to the publisher and with a bidding strategy, and the publisher will decide for us. Okay, and when you do that, if you understand this and you say this is going to be like that, what you want to do if you want to keep the collusion ring that Criteo is making is that you don't want to send all your campaigns, otherwise you're going to bid against yourself. So you want to find a compromise between giving lots of potential campaigns that the probability of winning is higher, and a small number of campaigns so that if you win, you're not bidding against yourself. Okay, so that's the question we are asking ourselves: is which campaign should we send, or how many campaigns should we send to a publisher if we want to win auctions if we want to maximize the revenue of auctions under the privacy sandbox. The second question we asked, and there was a paper by Hugo and normally by Hugo, is on Criteo, and there is also a student from EDF, because they have the same problem actually. At Criteo, there is not, when we are bidding for a user, there is usually not just one ad on one page, but there could be multiple ads. And we could assume that having one ad or two ads, no matter where the ads is the revenue is the same. So the question is, how many ads do we want to win per page? And at EDF, they have the exact same question, but with electricity, of course. And so we build a learning algorithm based on Bunny techniques, where we can improve the regress to minimize the cost actually of finding the optimal policy when we are bidding not for just one ad, but for many ads at the same time. So for auction. And then we have also a paper where what we want to do is we want to find optimal pricing. So when we do optimal pricing or bidding, you know that the price of the bid will depend on the features of each user. But the typical response for this in theoretical ML, actually, at least, is somehow to do some silo and separate the user and etc. I'm sparing the detail, but here the question that we ask is, can we use the concept of cross learning when you have different tasks and you're learning from one task to another, and can we do that to improve the rates of convergence, and how? And of course, I haven't said it, but all those questions, when I say can we and how, of course the answer is yes, and we have to read the paper to see those answers. And then in this paper by with Ahmed and Clément, we look at this question of when you are displaying ads, we are computing the performance of our ads based on what the advertiser or the retailer send us back as feedbacks. But maybe it could be the case that they have some incentives to lie to Criteo and say, and maybe there could be some conversions that has been hidden so that they don't paying us the conversion has been the conversion, and it could be in their interest to avoid declaring or giving feedbacks on those conversions. Of course, it's always on those kind of privacy settings. And in this paper, we're asking, can we actually enforce the advertiser to report truthfully? Can we give them some incentives to report truthfully, no matter what? They're going to give us all their knowledge so that we can make the best decision. And of course, they can. And so in this paper, we are mixing some game theoretic question with Bandit. It's quite interesting. So in the second type of question that we look at with online learning is if you want to do recommendation. So in the paper by Julien and Thibaut and Oussam, and I can read the next name, and what they look is when you're doing recommendation, actually you don't pick just one item, you don't make one decision, you can take many, you have many decisions to make when you're building a banner. And so the one banner is one complex object in a high combinatorial space. Okay, so you have many decisions, and if you take any possible decision independently, you cannot learn because you have too many. The combinatorics explodes, and you have too many choices, and you don't know what you should do. So to avoid this, you have to take some structure to make some assumption on the structure of the problem, and use this structure to improve the learning. And this is exactly what they did. They devised this new algorithm that adapts to the variance of the problem and improves the rates of convergence. Sort of the same kind of question. There was this paper by Othman, Imad, and people from Ensae that looked at the question as, can we do offline estimation in an efficient way of the data that have been gathered in online setting, online case? Because something I haven't said, but when you're running an online algorithm, the data that you recover are highly biased, but very, very, very biased, because basically you just get data that are interesting for you. So there is a huge bias in the data. So the question is, how can you unbias this data without losing too much? And this is what they are looking at in this paper. And finally, in the paper that I wrote with people from DeepMind and FAIR actually, and the students, we were looking at the game. That's why I mentioned games before. So we were looking at a complicated game like poker, to be more precise. And we were trying to do learning strategy in those games. And here the difficulty is that your opponent can hit some part of the space. And this is exactly what could happen in a setting where we are facing some competition at Criteo. That's why we're looking at this kind of question. And it's a very nice sandbox to look at problem. So at the other type of techniques we're using, now we go away from the bandits and into the online algorithm of the competitive analysis. We are asking ourselves those questions. If in reinforcement learning or in all of these kind of questions, we always consider that the reward of the future is their expectation. And we have no idea of what is the reward of the future. But now the question is, sometimes you can slightly anticipate the future. Sometimes you can know, maybe not the future in advance, the whole future, but maybe the next event, the next day, the next action. So you can see somehow in the future. And so the question is, what happens if you're able to do that? And it's something that is actually makes lots of sense if you're thinking of autonomous car. When an autonomous car goes into Paris, for instance, and then she has a decision between going left or right, or maybe at the crossing, she can see if one of the two street is crowded, and so she has some notion of the future. The future being the situation in which it will be in the next street, whether it's going to be in a crowded or not street. So that's something which is actually quite interesting in practice, and has never been looked before. Looking at what happens if you know a bit of the future. That's why this paper got a spotlight, meaning that it's only 2% of the paper at NeurIPS that got one, and I think it doesn't change anything except that you have a sticker on your poster. And the second paper here is actually the opposite somehow. Is when you're taking decision, we always assume that you cannot go back in time, and that's it. But sometimes, actually, maybe not at Criteo, but when you're doing display, but anyway, when we do attribution, for instance, or whatever, it's possible to go back in time. And the question we ask in this paper, in the second paper, Look Back Prophetic Inequality, with Ziad and Dorian, was what happens if we can go back in time and change our policy, or if we have some remorse and we are able to do it, even if there is a small cost, what is the gain? Actually interesting, the gain is huge. And so that's what we did. And finally, the last paper here is, so we want to do a budget balancing. There is a whole literature on budget balancing, typically called the prophet. That's the thing we see before. But what happens if you impose some fairness constraint? So if you assume, for instance, that you have two types of population, and it's very hard to compare population A against population B. So I know you know the typical example. So it's very hard to compare A against B. So you know that an element of A is better than an element of A, but you don't know one element of A and one element of B. You don't know how to compare them. So what is the cost of doing this if you can just make a small number of comparison and everything? So that's the kind of question we look in this problem. Say, well, let's focus on this question and assume that we have a budget actually of comparison, and we want to solve the classical problem. And finally, so here is
Can you wrap up now?
Yeah, it's over.
So
That's why it's much quicker because the last two papers are on the post-processing the data. That's what I said before. The last step is the post-processing. And actually, it's two papers that has been written by Maxime Bonneau, and he's going to present it, I think at 5, but I'm not sure. And the last one is a data set that has been published by Masha and Eustache on fairness. And she's also going to present it maybe at 4:30 or 5:30. I forgot. So stay tuned, and you will hear much more about those two papers in a few minutes. So that's it. So maybe I want to say again, because I'm still I have like minus 2 minutes. So I just want to congratulate all the members of the AIR, because this is something that has been done all together. And of course, something as I said before, when the first slide, is some of the paper has been accepted, some of them have not been accepted, but it doesn't mean that the papers that have not been accepted are less valuable than the other, than those that have been accepted. It's just a matter of maybe next time they're going to be accepted, and the work is exactly probably the same whether you get accepted or not. So yeah, congratulations to everyone on the group.
Thank you. I think we should take questions offline because we're a little bit over time already.
Thank you.